Hello everyone, today let's take a look at QP number 6, another conditional probability question, and this one's a little bit different from the ones we've been doing in the sense that this game could go on alternating forever, right? So we have two players, Jon and Ross, and when it's someone's turn, they're going to roll two fair six-sided dice. Now Jon wins immediately if he rolls a sum of 6 on his turn, and Ross wins immediately if he rolls a sum of 7, and if neither of them win on a given turn, then they keep alternating until someone does. So what's the probability that Jon wins if he goes first? So if we were to sketch out a probability space, basically what's happening here is Jon's going to go first, so he's just going to win on his first turn with some probability, and then if he doesn't win, it'll go to be Ross's turn. And then when it's Ross's turn, he's going to win with some probability and not win with 1 minus that probability, and then it would go back to being Jon's turn. And on Jon's second turn, well then he's going to win with, again, some other probability, and if he doesn't, then it would go back to Ross's, and then he would win with some probability, and etc., right? You can see that this just repeats forever. And then our probability space will end up looking something like this at the end, where green is the event that Jon wins and red is the event that Ross wins. Jon's side is composed of the event that he wins on his first turn, the event that he wins on his second turn, the event that he wins on his third turn, fourth turn, etc., all the way up to infinity, with these boxes getting smaller as they go. Then over here, Ross's side is also composed the same way, right? The odds that Ross wins on his first turn, second turn, third turn, fourth turn, getting smaller all the way up to infinity. In this question, first I'll talk about what it means in terms of conditional probability, and then we'll solve it using a geometric series, which is the hard and unnecessary way, and then I'll just show you the easiest way to solve it using symmetry. Now in this question, we're trying to find the overall probability that Jon wins, which I'll denote as P of J. And we know law of total probability, these partition our sample space, so we can break this up into the events that Jon wins, given that it's his first turn, times the probability that it's his first turn, plus the probability that Jon wins on his second turn, times the probability that it's his second turn, and all the way on up to infinity. Now when it's Jon's turn, he always has the same condition, so his odds never change. So the probability that Jon wins, given that it's his first turn, is equal to the probability that Jon wins when it's his second turn, right? Which is equal to the probability that he wins when it's any turn. So since these terms are all the same, we can pull this out and we get that this is equal to the probability that Jon wins given it's any of his turns times the infinite summation right here from k equals 0 to infinity of the probability that he even gets to this turn. So now what's the probability that Jon wins when it is his turn? Well, he has to roll 2 dice and we want them to sum to 6. There are 36 total ways to roll 2 dice. We know this, right? Just 6 times 6. And then we have to count out the integer partitions here that sum to 6. So it's 5, 1, 1, 5, 4, 2, 2, 4, and it's going to be 3, 3. So there are 5 different ways you can roll a sum of 6, so his odds are going to be 5 out of 36. And also, we probably should have done this in the first place, but I'll just draw a diagram to make it easier to visualize. So I'll have over here the event that it's Jon's turn. And then when it's Jon's turn, he has a 5 out of 36 chance of winning, so I'll call this over here the event that Jon wins. So 5 out of 36 times, Jon's going to win immediately, and the other 31 out of 36 times, well, he's not going to win, and then it's going to be over here, it's going to be Ross's turn. So now when it's Ross's turn, what's the actual probability that he wins? Well, Ross needs to roll a sum of 7 on his turn. There are 36 total ways to roll 2 dice, and he could get a sum of 7 with 5, 2, 2, 5, 4, 3, 3, 4, 6, 1, and 1, 6. So that's going to be 6 out of 36 equals 1/6 chance of winning when it is his turn. So we can add another state here. When it's Ross's turn, he has a 1/6 chance of winning. So I'll call this R win. And then when it's Ross's turn and he doesn't win, well, then it's going to go back to being Jon's turn. And that happens with 5/6 probability, right? Just 1 minus 1/6. So now in this infinite series, let's think about what all these P sub k's are. Well, first of all, the probability that Jon gets to his first turn is obviously 100% because it starts off as his turn, so P sub 1 will be 1. Now the probability that it gets back around to being Jon's second turn is equal to the probability that first he loses on his first turn, and then Ross loses on his first turn, and then it'll come back and it'll be Jon's second turn. So what's the probability of that? Well, the probabilities are independent, so it's just going to be 31 on 36 times 5 on 6, which is going to end up giving me 155 on 216. Then the probability that it gets back to being Jon's third turn is the probability he loses on his first, then Ross loses on his first, then Jon loses again on his second, and Ross loses again on his second, and then it will be Jon's third turn. So P sub 3 is just going to be this number squared, P sub 4 is going to be that number cubed, and etc. You can see how this pattern is going to repeat. So that's going to be a geometric series, meaning we can find a simple solution for this. So let's do that down here. Basically, I'm just going to have 5 on 36 times the infinite series from k equals 0 to infinity equals 0 because we start at 1. And then we're going to have our common factor of 155 on 216 to the power of k. So this right here is a geometric series we showed in Quantipus 64. How to solve this? All we do is we take 1 over 1 minus the common factor, which in this case is 155 on 216. And then in the denominator, when we subtract, we're going to get 61 on 216, and then we're going to invert it, so it's going to be 216 on 61. So this is the value of this infinite sum over here, and then we just need to multiply it by 5 on 36. And when we do that, the 36 is going to cancel from the bottom with 36 up here. It's going to leave us with 6 here, and then on the top, we're going to have 5 times 6, which is equal to 30, obviously, and then on the denominator, we're going to have 61. This will be our final answer. So that's the unnecessary way of solving it using the geometric series, but there is a much easier way if we just look at this diagram right here. So this is basically how you visualize a Markov chain. This is actually a Markov chain, a super simple one, but it is. And I'm sure we'll talk about that later, but to solve this, we can just use a super simple property of symmetry, right? A recursive property of this chain. And it's a property that we already noticed, but it's just that the probability that Jon wins on any one of his turns is the same. And that gives us this property that the probability that Jon wins is equal to the probability Jon wins on his first turn, plus the probability that it gets back to Jon's second turn. And then you'll notice that we're just literally right back in the same state as where we started initially. So we should have the exact same odds of winning as when we started. So the probability that Jon wins is just equal to some function of that same probability, because when it's Jon's turn, he has the same odds of winning every single time. You can see just this one recursive property makes our question so much easier, right? Now we can just basically solve for the probability of JW. So again, this would be equal to 155 on 216. So when we subtract this term to the other side, we'd get 61 on 216 times the probability of Jon winning is equal to 5 on 36. And then we'd get the exact same answer when we multiply both sides by 216 on 61. We get the probability that Jon wins is equal to 30 out of 61 again. Yes, obviously this way of solving it is a lot easier to think about and a lot easier to visualize with a diagram like this. So we're essentially just going to be using that method from now on, and it'll make things a lot easier.